This is linear second order equations, and in this video we will be talking about variation of parameters. So in this section we're going to be looking for a more general method for finding particular solutions. So here you can see we have our non-homogeneous linear second order equation. Of course, we have our constant coefficients. And this is linear second order. And what we're going to do is change colors here, y1 of t, y2 of t, be two linearly independent solutions for the homogeneous equation, that corresponding equation, which would be a y double prime plus by prime plus cy equal to 0. So we know that the general solution to this homogeneous equation was a constant times y1 of t plus another constant times y2 of t, that linear combination of both of those functions. Now, to find a particular solution to the non-homogeneous equation, we will begin the strategy of variation of parameters. So we will be replacing these constants by functions of t, or with functions of t. And as you can see, they are right here. And we will call them v sub 1 of t and v sub 2 of t. We will then substitute the derivatives of y of our particular solution, and we will then solve for both of these functions. So let's look at the method itself. So to determine a particular solution to this non-homogeneous equation, we are first going to find two linearly independent solutions, y1 of t and y2 of t, to the corresponding homogeneous equation, and then take this particular solution as follows. Again, we have replaced our constants with functions of t. We will determine those two functions, v1 and v2, by solving the system for v prime and v2 prime, and then integrating. And we will then substitute v1 of t and v2 of t into the expression for that particular solution. Now, in this step B, usually v1 of t and v2 of t are easy to derive. However, you could use these formulas, and they're pretty straightforward. I did want to make note that this denominator right here, this expression in the denominator, is called the Wronskian of y1 and y2. And I went ahead and put that definition here. Just wanted to make note of that. You will be seeing that throughout the course. So let's go ahead and look at our first example and see how this is going to work. Find a general solution using this method of variation parameters to y double prime plus y is equal to the secant of t. So we know that the functions y1 of t equal to the cosine of t and y2 of t equal to the sine of t are two linearly independent solutions to the corresponding homogeneous equation. So its solution, so that general solution to that homogeneous equation is equal to c1 cosine of t plus c2 sine of t. Now we're going to apply the method of variation of parameters to find that particular solution to the equation. So let's go ahead and use our form shown right here, and we can write y, that particular solution, as a function of t. Let me just rewrite that. Yp of t is equal to v1 of t, y1 of t, plus v2 of t, y2 of t. Now, since, and I'll go ahead and put that right below here, since y1 prime of t is equal to the opposite of the sine of t, and y2 prime of t is equal to the cosine of t, we can now write our system as follows. And we might want to go ahead and put that system here. I'll go ahead and put that right here. So that system we will be solving is y1 v1 prime plus y2 v2 prime is equal to 0, and there is our homogeneous equation. And then we have y1 prime v1 prime plus y2 prime v2 prime is equal to f divided by a. So that will be that system we will be solving throughout these problems using the variation of parameters. Okay, so let's go ahead and solve that system. And we have V, there's our system. So this is part B here. And we have V1 prime, and we can go ahead and say of t, multiplied by the cosine of t, plus V2 prime of t, multiplied by the sine of t, and that's equal to 0. And now we have the opposite of v1 prime of t multiplied by the sine of t plus v2 prime of t multiplied by the cosine of t. And that's going to be equal to the secant of t, because this is our f of t. Okay, so let's go ahead and manipulate these equations just a bit. We'll multiply that first equation by the sine of t and the second equation by the cosine of t. And let's see what we have. Put that over there. So we will have v1 prime of t sine of t cosine of t plus v2 prime of t sine squared t is equal to 0. And in our second equation, we'll have the opposite of v1 prime of t multiplied by sine of t cosine of t plus v2 prime of t cosine squared t. And that is now going to be equal to 1, because the secant is 1 divided by the cosine. Adding these together, I'm going to go ahead and put a line there, and I'm going to go ahead and put a line here. And adding these two equations together, you can see clearly that v2 prime of t multiplied by the cosine squared t plus sine squared t is equal to 1. And of course, we have v2 prime of t is equal to 1. So now from this first equation, and I can go ahead and number these. Let's go ahead and take equation 1. And as you can see, we have v1 prime of t cosine t plus v2 prime of t sine of t is equal to 0. And now that we have our v2 prime of t equal to 1, we can see that v1 prime of t multiplied by the cosine of t plus the sine of t is equal to 0. And you can clearly see that v1 prime of t is equal to the sine of t divided by the cosine of t. Whoops, and that would be the opposite, which is equal to the opposite of the tangent of t. So what do we have? We have that v1 prime of t is equal to the opposite of the tangent of t. We also have that v2 prime of t is equal to 1. So now let's go ahead and find v1 of t by integrating the opposite of the tangent of t, dt. And of course, that's the natural log of the absolute value of the cosine of t plus a constant. Now we have several constants that we have talked about in this problem. So let's just go ahead and call that C3. And we can also find v2 of t in the same manner, integrating 1 dt. And of course, that's t plus C4. So since we're looking for a particular solution, we can take C3 and C4 both equal to 0. So therefore, we have the particular solution equal to the cosine of t multiplied by the natural, we'll go ahead and put that in parentheses, the natural log of the absolute value of the cosine of t plus t sine of t. And you can see that right here. That's v1 multiplied by y1 and so forth. Here we have y1 and y2. Now, in order to find the homogeneous equation, whoops, so our general solution is going to be equal to that particular solution plus the homogeneous solution. And we come up with, let me just correct this here, the cosine of t, the natural log, absolute value of cosine of t, plus t sine of t. And now let's go ahead and add that homogeneous solution. We have C1 cosine of t plus C2 sine of t. Okay. Let's look at our next example. Find a general solution using the method of variation of parameters. And here we have y double prime plus 2y plus y equals e to the opposite of t. So this equation has an associated homogeneous equation, y double prime plus 2y plus y is equal to 0, and that auxiliary equation is r squared plus 2r plus 1 equals 0. And we have a double root, so r1 and r2 are both equal to -1. So therefore, that homogeneous, general solution to the homogeneous equation is YH of t is equal to C1e to the negative t plus C2, and we add that extra product of t in there since we have a double root, C2te to the negative t. Now, for the variation of parameters method, again, we want to go ahead and have, and I'm actually going to move this below just so that we have a little bit of room here for our particular solution. Okay. So now, taking a look at that, we will now have yp of t equal to v1 of t, y1 of t, plus v2 of t, y2 of t. Again, replacing our constants like we had in the homogeneous equation with two functions. We're going to go ahead and let y1 of t equal to e to the negative t, and y2 of t, or not let, we can see that y2 of t equals te to the negative t. So y1 prime of t is the opposite of e to the negative t, and y2 prime of t is equal to, of course, it's that product rule, and it is te to the negative t. Oops. It is 1 minus t multiplied by e to the negative t. Okay. So now let's go ahead and solve our system. And that system is this system right here. And we have e to the negative t multiplied by v1 prime plus te to the negative t v2 prime is equal to 0. And then we have the opposite of e to the negative t, v1 prime, plus 1 minus t, e to the negative t, and we have multiplied by v2 prime is equal to e to the negative t. And there's that f divided by a, which is 1. Adding these two equations together, we can see that we have e to the negative t v2 prime is equal to e to the negative t, which implies that v2 prime is equal to 1. So in order to find v2, we'll go ahead and integrate 1 dt, and that's just equal to t. Also, from that first equation here, we actually can have, dividing out e to the negative t, we would have v1 prime plus t v2 prime is equal to 0. And then we would have, since v2 prime is equal to 1, we would have v1 prime is equal to the opposite of t. And then, of course, looking at v1, we would integrate the opposite of t, dt, and we would have the opposite of t squared over 2. So with that, we're going to come around here, Let's move this over here. So now we will have that particular solution is equal to the opposite of t squared over 2e to the negative t plus t multiplied by t e to the negative t. And of course, we come up with t squared, t squared over 2 e to the negative t. So now we will come up with our general solution, and that's our particular solution plus the solution to the homogeneous equation. And we have t squared over 2 e to the negative t plus c1 e to the negative t plus c2 t e to the negative t. Let me go ahead and square that off. Okay, let's take a look at our next example. We have find a general solution using the method of variation parameters. And here we have a secant squared of 3t on the right-hand side. Let's first take a look at our homogeneous equation, the corresponding homogeneous equation. And we would have, and let's just go ahead and write that, y double prime plus 9y equals 0. So we have r squared plus 9 is equal to 0. And we have roots r equals plus or minus 3i. So y1 of t is equal to the cosine of 3t, and y2 of t is equal to the sine of 3t. Now, these are two linearly independent solutions, and a general solution to the homogeneous equation can be written as yh of t is equal to c1 cosine of 3t plus c2 sine of 3t. So using the method of variation of parameters, and we'll just go ahead and draw a line there, we now have a particular solution of the form v1 of t cosine of 3t plus v2 of t sine of 3t. So we are going to have a v1 prime and v2 prime satisfy the system, and we will have v1 prime of t cosine of 3t plus v2 prime of t sine of 3t. And then our second equation in the system is the opposite of 3, v1 prime of t sine of 3t plus 3v2 prime of t cosine of 3t is equal to the secant squared of 3t. That's our f. Okay, let's go ahead and multiply this first equation by 3 sine of 3t, and let's multiply our second equation by cosine of 3t. And then when we add them together, we should have a nice result. And there's that sine squared of 3t. And of course, it looks like I forgot to put is equal to 0 here in that for that first equation of our system. Let's do the same here. We're just multiplying by cosine of 3t. And here we have our cosine squared of 3t. And then we have the secant squared multiplied by the cosine. And that's just going to leave us with the secant of 3t. So adding these together, you can see that we have 3v2 prime of t multiplied by the sine squared plus the cosine squared is equal to the secant of 3t. And we have 3v2 prime of t is equal to the secant of 3t, leaving us with v2 prime of t equal to 1/3 multiplied by the secant of 3t. So let's go ahead and find v2 of t by integrating v2 prime. And of course, we come up with 1/9 multiplied by the natural log of the secant plus the tangent. I'm going to have to move this over. I don't even mind moving that. Oops. Over just a bit. Gives us a lot of extra room. And we have the secant of 3t plus the tangent of 3t. Okay, so now from the first equation in the system, and that would be this equation right here, we have v1 prime of t multiplied by the cosine of 3t plus v2 prime of t sine of 3t is equal to 0. So we can see here that v1 prime of t is the opposite of v2 prime of t multiplied by the sine of 3t divided by the cosine of 3t, and we can see here that it's the opposite of v2 prime of t multiplied by the tangent of 3t. So now in order to find v1 of t, we will go ahead and integrate. Whoops, and we'll go ahead and have to first plug in this opposite of this function. So it would be the opposite of 1/3 secant of 3t multiplied by the tangent of 3t. So that's what we will be integrating. So we will integrate the opposite of 1/3 secant tan of 3t. And of course, in order to find v1, that's equal to negative 1/9 the secant of 3t. So what do we have now? We have that our particular solution is equal to negative 1/9 secant of 3t cosine of 3t plus 1/9 sine of 3t multiplied by the natural log of the absolute value of the secant of 3t plus the tangent of 3t And that simplifies to negative 1/9 plus 1/9 sine of 3t multiplied by the natural log of the absolute value of the secant plus the tan. Okay, and now we have our general solution, y of t, and that's going to be our particular solution, plus the solution to the homogeneous equation, and we have negative 1/9 plus 1/9 sine of 3t, natural log of secant plus tangent of 3t plus c1 cosine of 3t plus c2 sine of 3t. And that is our general solution. See if I can square that off. Okay, let's take a look at our next example. Find a general solution using the method of variation of parameters y double prime plus 4y equals the cosecant squared of 2t. Taking a look at the corresponding homogeneous equation, y double prime plus 4y is equal to 0. So we have y1 of t equal to the cosine of 2t. I'll just leave that without parentheses. And y2 of t equal to the sine of 2t. Both of these are linearly independent solutions, so we can come up with a general solution. YH of t equals c1 cosine of 2t plus c2 sine of 2t. So looking at the variation of parameters method, we now have a particular solution of the form v1 of t multiplied by the cosine of 2t plus v2 of t multiplied by the sine of 2t. Let's go ahead and create that system. So we have v1 prime of t multiplied by the cosine of 2t plus v2 prime of t sine of 2t, and that's going to be equal to 0. Our second equation is the opposite of 2v1 prime of t sine of 2t, taking that derivative, plus 2v2 prime of t cosine of 2t is equal to the cosecant squared of 2t. So let's go ahead and multiply this first equation by the sine of 2t. And the second equation, if you can look closely, we will actually be multiplying by the cosine of 2t divided by 2, or 1/2 of that cosine, okay? So let's go ahead and take care of that. And we end up with v1 prime of t sine of 2t cosine of 2t plus v2 prime of t sine squared of 2t is equal to 0. And looking at this second equation, we are going to have the opposite of v1 prime of t, sine of 2t, cosine of 2t, plus v2 prime of t, cosine squared of 2t is equal to cosecant squared of 2t multiplied by the cosine of 2t. So if we add these two functions, two equations together, you can see that we have v2 prime of t multiplied by the sine squared of 2t plus the cosine squared of 2t is equal to cosecant squared 2t cosine of 2t. So we have v2 prime of t, and simplifying that, we can actually write that as, and actually I see here that we should just have a half here. It's not going to affect anything quite yet. That would be a 1/2. And then we will put this right-hand side in a nice form. We can have 1/2, and then now we will end up with the cosecant of 2t multiplied by the cotangent of 2t, which will be really nice to integrate. So we now know that v2 of t equals that integral of 1/2 cosecant cotan. And of course, we come up with negative 1/4 multiplied by the cosecant of 2t. Okay, let's now go ahead and look at this first equation like we've been doing, this first equation here, and we will plug in v2 prime. So from that first equation, we have v1 prime of t multiplied by the cosine of 2t plus, and here is our v2 prime, 1/2 cosecant of 2t cotangent of 2t multiplied by the sine of 2t, and that's equal to 0. So we can see that v1 prime of t cosine of 2t is equal to negative 1/2 cosecant 2t cotan 2t sine of 2t, dividing both sides by the cosine of 2t, cosecant 2t, cotan of 2t, and now we have the tan of 2t. And that's very nice because that's just equal to negative 1/2 cosecant of 2t. Let's go ahead and find v1 of t by integrating negative 1/2 cosecant of 2t dt, and we come up with 1/4 multiplied by the natural log of cosecant of 2t plus cotangent of 2t, absolute value. So now we have our particular solution, placing those in. So we have y p of t is equal to 1/4 multiplied by the cosine of 2t multiplied by the natural log of the cosecant of 2t plus the cotangent of 2t minus 1/4 cosecant of 2t sine of 2t. And that will simplify to 1/4, and we can just factor that 1/4 out. And we have cosine of 2t multiplied by the natural log of cosecant of 2t plus cotangent of 2t, and then we have that minus 1. So now we have